Welcome everyone to West Explains Best. Today we're going to be talking about points, lines, and planes, the very first chapter of geometry. Let's go ahead and jump right into it. Here we have point. You're probably thinking, what's the point? Well, a point is a location with no size and occupies no space. So, that's the same thing as no size, so I'll just shorten that up for you, but it's no size. Think that it's 0D, okay? 0 dimensions. Let me change the color there. So it's a 0-dimensional figure. It doesn't occupy length, width, height, depth, none of it, okay? So it's 0 dimensions. It's 0-dimensional. How do we name it? Well, if we have a point, and I'm going to make one real quick for you. There's a point. We name it with capital letters. So this would be point A. That would be the point there. You only use capital letters and you only name it with one capital letter. So make sure you just keep that in mind. And I've already done the diagram for you. Let me just actually move this over here and write one capital letter. One capital letter. Or you could just draw an arrow and be like, look at the diagram. That's how you label a point. So let's move on to line. Line, you guys have all seen before. It's a straight path. Okay, lines are straight. And they extend. That extends. They extend infinitely in both directions, in two directions. That extend infinitely in two directions. Okay, so we're going to start with a diagram again. This time we'll draw a line, and it's very important that we draw the arrows at the end. These arrows indicate that they'll continue on forever and ever. Now, how do we label it? Usually we need to have 2 points on here. So, for example, if we have a point A and then the second point B, then there has to be points on a line. In order for there to be a line, it's composed of an infinite number of points. So there are 2 points on a line, and we can use 2 of them to label it. Or we can use a lowercase letter. So sometimes we'll say line L, for example, when we use a lowercase letter. So there's 2 ways. Let me put a little bolt there and make it look a little nicer. So we can use 2 capital letters referring to the points, or we can use one, I should just write it out. We can use one lowercase letter. Not cursive. That's cursive, isn't it? No, I guess generally you use lowercase. I guess that kind of looks like cursive, but we'll just say lowercase. Letters. One lowercase letter. Okay, so that's how you label a line. Lines are fairly simple. Okay, they keep going in infinite direction. Now, plane. This is the one confuses my students a little bit. A plane, no, we're not talking about the thing that you book a trip on, and go from one place to another in the air. No, we're talking about a flat surface that extends infinitely in 4 directions. Okay, and I forgot to go back to this, but a line, how many directions does it go in? Well, it goes in 2 directions, but if we're talking about dimensions, it's all one-dimensional. It can either go left or right, so it's one-dimensional. Okay, now if we're talking about a plane, we're talking about the next level up, so we're talking about 2-dimensional. Whenever I think of planes, the best way I can do it is the original Mario. That's like the best way to think about this one is the original Mario gives you an indication of that you can go up, down, left, right, but you can't really turn and go sideways and see into the camera and rotate it and all that stuff. Okay, that's 3D, which we'll talk about a little bit later. Now, how do you label a plane? Well, first we should probably draw a plane. So planes, what do they look like? The best representation that you'll see from most books or diagrams or homework assignments or what have you, they'll look like this. Just to show that it's not a flat piece of paper. Well, it is a flat piece of paper essentially, but it's to show that it can be in any direction. Now, what do you need to label a plane, you need 3 points. So this is A, and we can have a point B, and then we'll throw in a point C in there. I know, very original that I chose A, B, and C, but that is true. Or I can also call it plane P, or some other capital letter. So we have 2 options again. We can say 3 capital letters representing points, or we can use the word plane with a capital letter. Notice how we said, I should probably write this, 1 capital letter with word line. So you have to use line L, for example, in this one. Okay, you'd have to say line L, but for this one, we can say plane P. So that's how you label a plane. Okay, let's go over some more terms before we can get into some problems. Collinear. Co means with, linear means line, so on the same line. On the same line. Okay, so if we're going to draw a line here and give a demonstration, okay, first thing we should probably draw is a line. Now, let's draw 3 points. So let's draw this one, and let's try to get creative with the names here. And then let's draw one right here. So let's call this point, we'll call it C. We'll call this one A, and we'll call this one T. Okay, maybe some spelling experts may have figured out the word I spelled. Maybe not, and that's okay. This is math, so you don't need to worry about it if you don't know what this spells. But we have points C and A and T. Now, C and A, let me write this down in case you didn't notice. Points C and A are collinear. Why? Well, they're on the same line. Okay? They're on the same line. The points C, A, and T, now we're talking about 3 points. Are all 3 points on the same line? Are not collinear. But keep in mind this is something that really confuses students, okay? You could always draw a new line that goes through any 2 points. So one thing we have to keep in mind, I'm going to put a star because it is pretty important. Let me change the color though. I don't like that. How about this? Any 2 points are collinear. Okay, so even though it doesn't look like T is collinear with A or C, it is, okay? But with C and A, it's not, okay? All 3 are not collinear because they'd have to be in the same line. But any 2 points are collinear because you can always draw a line through 2 points. Now, coplanar, you probably get what this means. This means co with, planar, plane on the same plane. Okay? So we're not talking about rows of passenger, we're talking about the planes that we had up here. I'm just going to copy and paste this, save myself some time, copy, paste. Okay, so we have plane P, and I'm going to make a little new letter. Let's call him G. Okay, so we have G outside this little plane, but we need to have another note here. If any 2 points are collinear, any 3 points are coplanar. So clearly we have A, B, and C are coplanar. But if we add a 4th point in there, that's when we need to be careful. So let me write that down. Points A, B, C are coplanar. But when we add a 4th point, that's when we need to be like, okay, let's take our time. Let's figure this out. Points A, B, C, and G are not coplanar. Okay, so they're not. When you have a 4th one and it's outside the plane as demonstrated here, I know it's kind of hard to visualize, but this is the best way we can do it in a book on a 2-dimensional surface, is show that this is outside of that 2-dimensional space, where these ones inside the plane are within that space. So these are within the space, this one is outside. However, you can always draw, like I said, you can always draw a new plane, okay, and this is really ugly, but you get the idea, through 3 points, and they can be all coplanar. So I drew a new one through G, A, and C, showing, or yeah, G, A, and C, GAC, showing that they can all be coplanar. So just keep that in mind. Any 3 points are coplanar. I'll even highlight that in green. Okay, we got some more shapes. I know you guys were not having enough fun with the ones we covered, so let's add a few more in there. So a segment. What is a segment? Well, a segment is kind of like a line, except it doesn't have arrows at the end of it. So it's a part of a line. Part of a line with two endpoints. So just saying a line with two endpoints. I don't really like that part, so let me get rid of that. I'm going to say no to that. A line with two endpoints. There. That's cool. So basically we're just going to take our line that we had before, okay, and we're going to get rid of the arrows at the end, and instead the endpoints are going to be, that is ugly, the endpoints are going to be the points. So this is now a segment. So we have A and B, and this is a line segment. Now how do we label it? Well, we need to label it with a and a B. This is how we call it. And then we draw a line over it like this. Okay, so AB line. Or this could even be BA. Why am I doing this in black? It could be AB with a line over it or BA with a line over it. Now, I know what you're thinking. Mr. West, you did not go over this with the other line. You are correct. I need to go back and show you. So we already had point A labeled, and now if we're talking about AB up here, for a line that extends infinitely in all directions, you need to have a line with two arrows on top of it. And you're like, oh, now I get it, okay? The line on top indicates what type of line we're talking about. Is it a segment or is it a line? And notice how you can call it either one, BA or AB. It's reversible, okay? Because it's going to be the same thing no matter how you do it. Same thing with the line segment. You can call it AB or BA, okay? So, and the last thing I want to say, sorry, I'm jumping all around here. We can call this plane P, or we can call it plane ABC. But you need the word plane in front of it. Okay, plane ABC or plane P. Array. So what are we going to do with array? Well, array is a part of a line. I don't like that part. It's a line with one endpoint. Okay, so now we only have one endpoint. What does that look like? Well, it's going to be, you still need 2 points. Remember, you can have an infinite number of points on a line. I'm going to be super creative here and do A and B because that's, so original. So we have point A, point B, and we're going to have a line that goes through it. Okay? But it has an endpoint, only one endpoint, and that means it stops there. Okay? Now, how do we label the array? Well, with array, notice this is very important, the order. With segments and lines, it's not important. With array, it is. So we have AB. Oops, B is blue, isn't it? We have AB, and it's going to have a line on top of it, but it has to have an arrow. And notice how the arrow goes through B. So you need to have the arrow go through B, towards B, on the top. I'll show you what's unacceptable. Unacceptable is this. Okay? You don't want this because this would indicate that B is the endpoint and A, the line goes through that. That is incorrect. You want to start with your endpoint on the left. So this is your endpoint. And you want to, this is the point it goes through. So the point arrow goes through. I don't know of a more eloquent way of saying it, so I'm just leaving it like that. Opposite rays. Well, now we have we're talking about two rays. Two rays with a common endpoint that form a line. So kind of like a very specific case here, but still important because it's kind of the foundation of some other pieces. Yeah, so we're essentially just talking about, let's draw a line. Okay, and let's try to make it a little bit more creative. I'm going to go A, and I'm going to go, look at this, going wild here, C. Okay, and then we'll go back to basics, and then we'll call this guy B. Okay, so I have A, B, C. Probably fooled you. Okay, so we have A, B, and C. I'm just going to go straight purple here. We'd have two rays here. One ray would be B, C, arrow. Keep in mind, B is the end point of this particular ray. You're thinking, well, there isn't an end point. It's in the middle of the line. Well, we can still call it a ray if it's like build your own ray. Out of a line, you can build your own. Okay, so we built that one there, and that's ray BC. Okay, now what we're going to do is we're going to make another ray, and the other one that shares that same endpoint is BA. So we have BC and BA, and those are opposite rays. Okay, but it's very important that they have to share the same endpoint. So let me highlight this here. This endpoint needs to be the same in both of those rays. That's what you call opposite rays. I think I'm going to do this in part 2. Split this up into 2 videos. I think that makes a little bit more sense since I've already kind of gone significant time now. So this is kind of like the definition. Stay tuned when we're talking about some examples and see what this is all about. Space. Tune in next time. See you soon.